Hello students, how are you? I hope you are all fine and studying. Have you seen the earlier parts of this video? The chapter light. I hope you have understood something from those videos. Now here we are going to continue this chapter. This is a new topic. You will guess this topic. What is this? Okay. Now here these phenomena you might have observed them sometime in your life. Now here you can see that when we see this light, a ray of light passing through a glass lamp, how it bends here. Okay, and here also when it is a beam, a small single ray of light is passing through a prism, what happens to it. And then here a pencil dipped in water, so what happens to it? So these phenomena are due to refraction of light. Now, so we are going to see what is meant by refraction of light and what is responsible for all these phenomena. Okay. Now, when a ray of light enters from one medium to another, then it bends, its direction changes. When it is emerging, you can see that this ray will be a straight line from here to here, but when it is in the glass, it bends in some direction. The angle here is 60 degree, the angle of incidence, but the angle of refraction is 34.5. It means it bends towards the normal, right? Now why does this ray of light bends? Now when it is traveling from one medium to another, then the speed of light changes, and because of that this bending takes place. Okay, so this bending of a ray of light, when it is at the interface between the two surfaces, this is the boundary which separates the two media, air and glass, and in this case air and water. So this is the boundary. So at this interface the ray of light will change its direction. It bends. So this bending of a ray of light at the interface between the two surfaces is known as refraction of light. Now again here you can see when the medium changes, it bends. Refraction of light through a glass lamp. This is for your practical also, so we'll perform this in class. Now this is one medium, air, and this is another medium, glass. When this is known as the incident ray, this is refracted ray, the bent ray, and again it is refracted, so it is known as the emergent ray. Now once the refraction takes place at this interface between air and glass, and here also at another interface between glass and air, so at both the times, so this incident ray and the emergent ray would be parallel to each other. So when a ray of light enters a denser medium from a rarer medium, air is a rarer medium and glass is a denser medium, so it bends towards a normal. And when it enters a rarer medium from a denser medium, it bends away from the normal. Okay, so this you have to remember. This is refraction through a glass lamp. So definition: the phenomena of bending of a ray of light at the interface between two media when it travels from one medium to another is termed as refraction of light. Now here the laws of refraction, as we have studied the laws of reflection in the same way, the incident ray, the refracted ray and the normal to the surface of separation of two transparent media at the point of incidence all lie in the same plane. This is same as the first law of reflection, same way. Here the second is the ratio of sine of angle of incidence to the sine of angle of refraction is a constant. You know what is sine of angles? So the ratio of this sine I upon sine R is a constant value. This is known as a Snell's law of refraction. Okay. Now refractive index, what is meant by refractive index, how to find the refractive index. So the refractive index of medium 2 with respect to 1 is given by the ratio of the speed of light in medium 1 and the speed of light in medium 2. If this is medium 1 and this is medium 2, so the refractive index of medium 2 with respect to 1, in the next slide we are going to see how to write this. So it is given as the ratio of the speed of light in the two media. Okay, and it is denoted as 2 1, n 2 1. It means refractive index of medium 2 with respect to 1. So here this is the formula for finding the refractive index. So this is n 2 1. It shows the refractive index of medium 2 with respect to 1. So speed of light in medium 1 divided by speed of light in medium 2. And opposite also true. It means that if it is medium 1 to 2 means n to 1, then again if we reverse the order, refractive index of medium 1 with respect to 2, you take here speed of light in medium 2 divided by speed of light in medium 1. Okay, so both are true. So this is the formula for finding the refractive index of different substances. This table shows the refractive index of some common materials. Now if the substance is dense, high optical density, if it has high optical density, its refractive index would be more, okay, high. So air is said is very rare, so its refractive index is also less. You can see here in this table, you can compare different substances. Optical density is different from the common density which we study in the physics part. Okay, so I hope you have understood. We'll continue in the later videos. Stay home, stay safe, and keep learning. Bye.